5,000 baht for duration, but I got this creepy incubator. If God exists, if the God exists, please help me.
It's broken, just buy a new one.
I am a god. Actually, I've never seen anyone cry just because of a lab incubator. So because of this, I will give you some go. So why don't you change and replace that insulator instead? Anyways, I'm out. Bye.
Aerogel is made of two main parts, a solid framework and air. The solid framework is usually made of silica, metal oxide, or carbon, which form a three-dimensional network of the tiny particles. This solid part only makes up about 1 to 10% of the total volume. The rest of the material is what? It's air. About 19 to 99.8% is only air that we breathe in. This air is trapped inside the extremely small space called nanopores, which are thousands to million times smaller than the hole in the sponge. Because these pores are so small, so the air cannot move freely. This prevents heat from transferring easily and making this aerogel a very good at insulator. So, even though aerogel is mostly air, its unique nanoporous structure allows it to remain solid and being extremely lightweight and highly effective at insulation.
So moving on to the core applications of this material, we focus on three primary functional areas. So first is ultra lightweight engineering. Because this material composed up to 99.8% air, this allows to provide stable structures matrix at a fraction of weight, which is a critical advantage in aerospace and high-performance design. So second, the material excels in acoustic damping. Its nanopore structures is designed to scatter and absorb sound wave. This transforms it into a high-performance acoustic insulators. And finally, we have extreme thermal insulations. As you can see from the demonstration with the flowers and the flames, it acts as a near perfect barrier against heat transfers by effectively nullifying both convection and conductions. It protects delicate components from extreme temperatures.
Aerogel starts from a silicon-based liquid that reacts with water to form very tiny silica particles. These particles are suspended in liquid and poured into a mold. As the reaction continues, the particles link together and form a gel. This gel looks like solid, but inside it is like a sponge, with a very small pore filled with liquid. Next, the liquid inside the gel is cleaned and sometimes replaced with liquid carbon dioxide. This helps remove impurities and make the next step safer. Then, the gel is placed inside a sealed pressure vessel so that the temperature and pressure can be carefully controlled. The most important step is to supercritical drying. The gel is heated and pressurized above the liquid's critical point, where the liquid becomes supercritical fluid. In this state, there is no surface tension, so the liquid does not pull on the structure and cause it to collapse. Finally, the pressure is slowly released, turning the fluid into gas. This leaves behind the aerogel, a dry, extremely porous material made mostly of air.
Why do we choose aerogel? Because it is a material of extremely light, extremely thermal insulation, and extremely acoustic insulators. In future, we can adapt it in firefighter suits to protect them from fire. Make the fridge from it so we can save the energy. Or making a box of aerogel to use for organ deliveries. Make the slant of it so it can reduce the noise from construction sites. This is why this is the material for the future.
Let's look at where this technology is being deployed. So in the field of aerospace, aerogel have been a cornerstone of Mars exploration for so long. So it provides thermal insulation required for sojourner spirit and opportunities, protecting their sensitive electronics from extreme temperatures. And beyond insulation, it plays a vital role in Stardust mission in 1999, where its unique structure allowed it to capture high-velocity interstellar dust samples without damaging them. Closer to us in architecture, silica gel is being integrated into energy-efficient windows because it's highly translucent. It allows natural light to enter while completely blocking thermal transfers, And finally, the material is also revolutionizing extreme weather gears. By incorporating aerogel into specialized outdoor apparel, manufacturers can create clothing that protect against sub-zero temperatures without restrictive of synthetic fields.
And here is my collected 7 population validation tested value before you make some consideration. Number 1, we will talk about the thermal conductivity. And the lower K value you got, the better insulator it is. Second value is about the water resistance. And if the difference percentage weight of that object is lower than 1 to 4% by weight, this means your object is water resistant. And one thing that I like is about the durability test. By making some thermal cycle between the very hot area and the very cold area for many times. So the more it changes, the less durability it is. And the rest of them is really simple. For combustion test, we will use the machine. If you got the PSI more than 3, your object is really strong. And surface burning, your job is to observe your frame. If your lens burn is less than 5, it resists burning. The density is the mass divided by volume. And the dusting rate is that to vibrate to make a dust and measure its weight of those vibrated dust. That's it. So in order to help out, I want you to make some workshop with this. The above area is about the traditional insulator and the below one is our aerogel. And you can see that the more temperature, the more traditional insulator will be heated. Anyways, our pyrogel can do the job as the insulator better. And on top of that, its density is more lighter than water for 5 times. Also, it is hydrophobic. And from the ASTM C165, which is talking about the compressive resistance, it can perform very good. The water absorption is very low, so this is a water resistance. It's also a fungi resistance and it's really safe to be burned in the lab. What's a good material it is?
Comparisons. We compare between fiberglass and aerogel. In aspect of thermal insulation, the thermal efficiency of aerogel is 0.013 watt per meter Kelvin and about fiberglass is 0.044, which means aerogel are better. About the weight, the density of aerogel is 20 kg per cubic meters and the fiberglass is 40.1 kg per cubic meter, which means it's 2 times. And the last, aerogels are more expensive than fiberglass. And this is reference. Members, and thank you for watching us.